18, y equals the absolute value of x. Good. So this is number 18 on page 10. Y equals the absolute value of x. Here we're asked to graph. So whenever we're asked to graph a function, we will go through the following steps. Number one, we have to identify the domain. Number two, we have to create a table of ordered pairs. And only number three is the graph itself. Good, so let's go back to number one. Can anyone give us the domain of this function? And what type is it? So I need to identify it. Type first. What is the type? What type of function is it?
Is it an absolute function?
Very good. Absolutely. Who said that?
Megan.
Thank you. It's an absolute value function. I just from the reading it, with the way I read it, it's y equals the absolute value of x. It must be an absolute value function. Awesome. Good. What about the domain? What is the domain of this function? In other words, I'm asking what can I plug in here? What could x be?
Would it be oh, sorry.
Go ahead. I can listen to
negative infinity to positive infinity.
Very good. All real numbers. So now I can start my table. I cannot start my table before that. Y or f of x is the same thing. Very good. Awesome. So domain is all real numbers. What could be a restriction? Fractions have the restrictions. Log functions have restrictions. Radicals. These are functions with restrictions. Fractions, logarithms, radicals. These are not friendly functions. They could be, but for these, when I work with fractions, logs, and radicals, I have to be very careful. But this is a friendly function, what I like to call it, friendly. Good. So let's pick some values. Let's say -3, -2, -1, of course 0, 1, and 2. Can anyone give us the y values for these? Anyone who said nothing so far? I don't think I heard Liam and Jessica and Matt. Anyone? Or anyone else?
Would it not be in 3, 2, 1, 0, 1, 2?
Excellent. Very good. Who was that, Tyler?
Mm-hmm.
Perfect. Great. So now, can anyone give us the ordered pairs from left to right that we need to use to plot? Can anyone read the first two ordered pairs?
-3 and 3.
Excellent. Was that Nick?
Anthony.
Anthony, sorry. Thank you. Okay, very good. -2, 2. Perfect. -1, 1, 0, 0, 1, 1, and so on and so forth. Very good. So here it is. We should remember the absolute value function as what is called a v function. So y equals the absolute value of x. I want to add number 4 to our list. 1, 2, 3, 4. And I would like someone to tell us what is the range of this function.
Be 0 to infinity.
Correct. Remember how we determine the range. I go I imagine that I cross this graph with horizontal lines starting from negative infinity. Does it cross? No, 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 no. 0. Yes, 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 yes. So the range is indeed 0 to infinity. Good. I would like to move on and look at some word problems now. So let me share my screen again. Any questions? Anyone?
Yeah.
Yes?
Your notation for domain versus range. For domain, you had parentheses, negative infinity through infinity, but range, you had an open bracket for the open bracket 0, and then infinity and parentheses. What's the significance of that?
Very good. This is not an open bracket. This is a closed bracket. This is open. When it's open, it doesn't exist. When it's closed, it exists. Infinities are symbols. I can never use a bracket on infinity. So the bracket really says 0 is included. If I have 0 to 2, it means 0 is not included, 2 is not included. Is this okay, everyone?
Mm-hmm.
Moving on. Other questions? Okay, great. Good. So I would like us to look at word problem. Here is one thing that I would like to look at, and just quickly identify the domain and range for this. The number n in millions of hearing impaired Americans of age X. X is the age from 0 to 92.3. So obviously this is the domain between ages 0 to 92.3. Can anyone identify the range on this?
0 to 6.
So 0 to 6 in millions. Careful, right? From 0 millions to 6 million, right?
Right.
Okay, very good. Now, if I want to read from this graph, the next question, let's take a look, because I have to come back to the graph. So approximate the number of hearing impaired Americans for ages 20, 40, 50, 60. Okay, so let's go back. So can anyone read for us roughly an approximation? That's what it says. Can I zoom in the book? Will allow, oh yes, awesome, very good. So will it allow me more? It's not doing it that much.
I believe the magnifying glass is a search function if you were looking for a specific, like,
I just wanted to zoom in.
I think if you hit Control plus on your keyboard, it might zoom
My
in.
keyboard is in the kitchen. No, I'm kidding. He's far away. So you said Control plus? Yes?
Yes, that works on mine. It might not work on everybody. There we go.
Okay, better. Okay. Good. So for 20, let's approximate. What would you say for 20?
1.75
Right.
million.
Exactly. So when x equals 20, imagine that you draw a vertical line, you see the intersection right here, and you go to the right. I'm sorry, of course, to the other right. So you go to the left and check and read on the y-axis. So for x equals 20. Then they were asking us for x equals 40. Almost at the intersection of the grid. So about 4 million. And for 60, about 6. And they also want, that's it, to 2040, 2040, 50. Okay, they also want 50. So again, for 50, I will approximate it's below 5.5, potentially 5.3 million. Difficult to read. That's why I wanted to zoom in as much as I could. Okay, any questions? Now, what if they're asking us, and they are asking us, for what ages is the number of hearing impaired Americans? Approximately 4 million. Okay, so let's take a look. Where is my button back? Sorry, guys, you're in the way all the time. I'm kidding. Okay, so how do we determine for what ages is the number of hearing impaired Americans approximately 4 million? How do we do this? We imagine now that we draw a horizontal line at 4 million. Imagine we draw a horizontal line, and now we will be reading the age. So at 4 million, it crosses in this point and this point, and I will be reading the X values. 40, oops, 40, and I didn't mean that, and 80. So please write it down for part B. We have at 40 and 80. Okay, let's look at part C. Part C. Estimate the age for which the greatest number of Americans is hearing impaired. Okay, so here is the maximum. Somewhere it appears that the age of 65, 64, that's the peak, that's the highest, and that would be 6 million. Okay, and there is a last part, I think. What difficulty do you have in making this determination? I'm not sure which they're referring to. Let's assume that they are referring to part C. So the difficulty is because it's difficult to read from the table. I'm sorry, from the graph. I don't have a table of values that they use to graph this function. So, and I don't have the function. So no one gave us the polynomial function that represents this graph, or maybe another type of function. We don't have it. So I cannot plug in a function and give you the exact, even that is, it's probably not going to be 100%. So we don't have the data set. We don't know exactly where it is. Okay, moving on. Let's talk about compound interest. And then we'll come back to these type of problems. Okay? So we have semi-annually, we have daily. They're not asking us about continuously, but I will give you both formulas for compound interest, compounded n times a year, and also compounded continuously. Okay. Let me see how I am with time here.